Today we will solve the problem 4.46 of Griffith third edition Introduction to Quantum Mechanics. The problem 4.46 is consider the three-dimensional harmonic oscillator for which the potential is V of R is equal to 1 over 2 m omega squared r squared. So here r squared is equal to x squared plus y squared z squared. This problem consists of two parts. Part A is so that the separation of variable in Cartesian coordinates turns this into the three one-dimensional oscillator and exploit your knowledge of the later to determine the allowed energy. The answer is E of n is equal to n plus 3 over 2 multiplied by h cross omega. So, for a three-dimensional harmonic oscillator, the Schrödinger equation is minus h cross squared over 2m delta 2 over delta x2. This depends on x and plus delta 2 over delta y2 plus delta 2 over delta z2 multiplied by psi, the wave function, plus of m omega squared. This r squared I have written as x squared plus y squared plus z squared, of course multiplied by psi, which is equal to E psi. Now we will try to rearrange and simplify this. Now we got this expression. What we are going to do is replace psi of r by x, capital X, which is a function of x alone, and capital Y, which is a function of y alone, and capital Z, which is a function of z alone, and divide it by x, y, z. Then you will get and group the term x squared and y squared and z squared. So this will become minus h cross squared over 2m 1 over capital X t2x over tx2 plus half m omega squared x squared. Because you are replacing this by xyz and dividing by xyz, this right hand side also. So in the first case x squared, if you divide this by xyz, only x retain, yz will get cancelled. So same thing is the with the second term, that is minus h cross squared over 2m 1 over y delta 2x over delta y2 plus half m omega squared y squared and for z, which is equal to E, because we are multiplying and dividing by we are replacing psi by xyz and dividing by xyz. Here also xyz will cancel with xyz. Here also xyz will cancel with xyz, except this here. Here only 1 over x retained, here 1 over y and here 1 over z. Now you take the first term in the bracket and the right hand side. Right hand side can be written as E, can be written as E sub x plus E sub y plus E sub z. That is energy along x direction and y direction and z direction respectively. You take this and equate this to E sub x. Then you multiply this equation by capital X. Then this 1 over x will get cancelled. Then you will get here 1x and here 1x. This will become minus h cross squared over 2m delta t2x over tx2 plus of m omega squared x squared capital X, which is equal to E sub x capital X. Here you can notice that I have replaced the partial derivative into full derivative, because this depends only on x. That is the reason why I have replaced partial x to partial derivative to full derivative. Similarly for y, I will get this one. So instead of x, I am getting y. Similarly for z, I will get like this. Now we will find the final answer for this. Along x direction, we got this relation. This is equivalent to one-dimensional harmonic oscillator, Schrödinger equation. So the E sub x is equal to n sub x plus half h cross omega. This is the nth energy state of the harmonic oscillator. Here we are considering the harmonic oscillator along x direction. Similarly, along y direction, this is equal to ny plus half h cross omega. Along z direction, E sub z is equal to nz plus half h cross omega. So En, the total nth energy, state energy level is E sub x plus E sub y plus E sub z. You add these two, these three. So 1 over half, 1 over 2, 1 over 2, 1 over 2. You will get 3 over 2. And nx, ny, nz. We will get is equal to nx plus ny plus nz, 3 by 2 h cross omega. So now we can write En is equal to, we have seen En equal to Ex, Ey, Ez plus Ez, it is equal to this one. Then Nx, Ny plus Nz is equal to, simply we take N. So this is equal to N plus 3 by 2 h cross omega, where N is equal to Nx plus Ny plus Nz. This is the nth energy state of the harmonic oscillator in 3 dimension. So only difference is here, instead of 1 over 2, we are getting 3 over 2. For one dimensional harmonic oscillator, the ground state energy is half h cross omega. You know it very well because n equal to 0. In this case, it is 3 by 2 h cross omega. So ground state energy itself 3 times that of the ground state energy of the one dimensional harmonic oscillator. Then next we will move on to the part P. Next question is determine the degeneracy Tn of E sub n. Let us take nx, I will explain using this table, nx, ny, nz, n. So first you take nx, ny, nz, all three are 0, that is ground state energy. As I said earlier, the ground state energy is 3 by 2 h cross omega. So now you have only one state, single state. So degeneracy is 1. Here n is equal to 0. So generally what is n prime here? N prime is equal to n plus 1. So if n equal to 0, n prime is 1, that is degeneracy is 1. Now next you take n equal to 1. So there are three possibilities, 1, 0, 0, 0, 1, 0, 0, 0, 1. So there are three possibilities. You have three. Here interestingly you can see the En is equal to, we have seen just En is equal to n plus 3 by 2 h cross omega. So n is 1, you will get pi by 2 h cross omega. You have three possible state. So if n is equal to 1, number of degeneracy is 3. So this is first case, n prime is 1, n is 0, that means n prime is 1. Here what is n prime? N prime is 2, n is 1, so n prime will be 2. That is, here you have 1, 1 plus 2 you will get 3. Here n prime is 1, here n prime is 2, that is n plus 1. N plus 1 is 2 here. N is 1, n prime is n plus 1. So 2, that you have to remember. This is some mathematical trick only. You have three possible state. How you got this? 1 plus 2. That is, you are adding the value of n prime. N prime is 1 here. n prime is 2 here, 1 plus 2 you will get 3. Similarly, for n equal to 2, that is there are 6 possibility. 2, 0, 0 is equal to 2, one possibility, and shift this 2 to ny. 2 along y direction, it energy state is doubled, 2, 2 and z 2. So that is 3 possible value here. And another possible value is 1, 1. 1 plus 1 is 2. And 0, 1, 1, 2. And 1, 0, 1. This is 3 possibility. So 3 plus 3, you got 6. So here you can see n equal to 3, you will get 3 plus n equal to 2, sorry, n equal to 2, you will get 4 plus 3 divided by 2, that is 7 by 2 h cross omega. Here you can see how you are getting this 1 plus 2. I am adding only n prime. N prime is here 1. First case it is 1. Second case it is 2. Third case, this is n prime is n plus 1. 2 plus 1. N prime here is 1 plus 2 plus 3. So in the last case, n prime is 3. You add 1, 2 plus 3, which is equal to 6. You have 6 degeneracy. Then we will move on the table further. Now let us take n equal to 3. So there are 10 possibility here. 3, that is nx3, then ny3 and nz3, all others are 0. Then 2 plus 1, 2, 1, 2, 0, 1, also 3. And 1, 2, 0, also 3. I am shifting to the next, that is ny. From x to y I am shifting. So here you will get 1 in the x and also y 1 in z. Similarly, 1, 0, 2. And now I am shifting to the z axis, z. Then it will be 1, 0, 2. Then 0, 1, 2. There are the 3 possibility. So you have 3 possibility with 3, number 3. Then there are 6 possibility with number 2. There are 6 possibility. This is 3, this is 6 possibility. And there is unique probability, that is 1, 1, 1, also 3. So this one. So totally you will get 10. Totally you will get 10 degeneracy. Here n prime is equal to 4, because n equal to 3, n prime is equal to n plus 1 we have seen. Systematically we got this. And the energy is 9 over 2 h cross omega. Then here n is equal to, you can see n is equal to 3, so n prime is 4. So earlier we got n prime is 1, first case, second case 2, third case 3. Now here the fourth case n prime is 4. If you add all these 3, it's a systematic variation. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. You got it. So you remember that you are adding consecutively. Then we will move on to generalize this. Now we will see generalize the expression. So we got when n equal to 0, n prime is equal to 1. So number of degeneracy, that is Tn, number of degeneracy is Tn prime, we will see, is equal to 1. When n equal to 1 we have seen, that case n prime is equal to 2. Then degeneracy n prime is equal to this 1 plus 2. You got 3. Then when n equal to 2, that is n prime is equal to 3, then degeneracy, number of degeneracy is equal to, you have to add all these three, 1 plus 2 plus 3, we got it 6. Similarly, when n equal to 3, n prime is equal to 4. Now degeneracy is equal to 1 plus 2 plus 3 plus 4, which is equal to 10. You will keep on adding this number. So general equation is the degeneracy n prime is equal to 1 plus 2 plus 3 plus, it will go on. So if you add the integer number, generalized formula is n prime into n prime plus 1 divided by 2. Uh, but we have to find the degeneracy with respect to n. So this here we can see n is equal to n prime is equal to n plus 1. N prime is equal to, here 0, 0 plus 1, here 1, 1 plus 1, 2, here 2, 2 plus 1, 3. So n prime can be replaced by n plus 1. Then this will become n plus 1 plus 1, n plus 2. This is a generalized formula is number of degeneracy is equal to n plus 1 into n plus 2 divided by 2. This is the general expression. Thank you very much for watching my videos and supporting me continuously. Thank you very much.